Okay, so hello everybody, and we'll now pick up on part 4, comparing net present value and IR, internal rate of return, and see how they kind of look. And what's a net present value profile? Now, this is a profile. It's a graph that depicts projects' NPVs, net present values, calculated at different discount rates. All right, so to prepare net present value profiles, here's an example from your book for Bennett. There are two projects, A and B. So we have to develop a number of discount rates, right? And they're called these coordinates, right? 3 coordinates are easy to obtain for each project, and 0, 10, and the internal rate of return. So the net present value at a 0 discount rate is the sum of all the cash flows minus the initial investment. Okay. So we basically just go through these coordinates here. And for project B, we go through these coordinates. And we come up with this, right? So the net present values for project A and B at the 10% as follows here, which, right, I write here, right? And because the internal rate of return is the discount rate for which net present value equals 0, basically the internal rates of return of 19 and 21 result in the 0 NPV, where it crosses the x-axis, right? Everyone see that? Where it crosses the x-axis. All right, so you can just go through and make a graph. So basically, what they're doing here is they're just graphing different costs of capital, right? Different costs of capital versus the net present value. All right, so this is important here, okay? This is important here. There's 3 important facts. The internal rate of return, excuse me, of project B is greater than that of project A. So managers using the internal rate of return method to rank projects will choose B over A if both projects are acceptable, okay? All right, so that's that's pretty obvious already, right? The net present value of project A is sometimes higher and sometimes lower than that of project B, depending on the discount rate. Thus, the net present value method will not consistently rank A above B or vice versa. And so the net present value will depend on the firm's cost of capital. But in reality, the net present value is much more reliable than internal rate of return. So when the cost of capital is approximately 10.7%, project A and B have identical net present values. So the curves cross each other and they jog all over the place. So the best way to ever deal with net present value and internal rate of return is to graph the the curves to see what they look like. Okay, you got to graph the curves and take a good look at them, because you don't really know what's going on. And I'm going to show you that in future slides. All right, so if you look in your book at the graphs, you'll see what they're kind of saying here. So you can see the problem right away. The net present value and internal rate of return methods rank the 2 projects differently. Okay, and the only way you get to know that is by looking at the graphs. So you have conflicts in the rankings, okay? Okay, so here's the discount rate, right? and here's a right for projects A and B for about 3 or 4 different discount rates. Here's where the net present value equals 0. Okay, so this is the internal rate of return we calculated. So at 0, this project is higher. It has a higher net present value, and at 10, this project also has a higher net present value. But look at project B. It's got a higher internal rate of return. So you can clearly see there's dilemmas when dealing with these. Okay, so here's the graph I was talking about, and this is an important graph. Here's project A and here's project B. If your discount rate or cost of capital is above 10.7%, you would choose project A. Everyone see that it's got a higher net present value? Look at the blue curve. Everyone see that? This is why there's conflicts and why it's important to graph everything. You'll notice how that is. Okay, you get conflicting rankings here. So now, if your discount rate is greater than a 10.7, all of a sudden now, look what's got a higher net present value. Look at the red curve all of a sudden. Now the red curve has the higher net present value. So this is why you're getting conflicting rankings. See, it's got the higher internal rate of return. So at the crossover point, all of a sudden, this is why there's a problem with internal rate of return, okay? But it's important to graph it, okay? So depending on your selected discount rate, you have to see which project is better doing. So so internal rate of return says project B is you should do because it's higher, but net present value below 10.7, and I believe your example internal cost of capital was 10, right? So that's why it was telling you to do project A here. Okay, but this is a real important graph. So we get these things called conflict rankings, and conflicts in the rankings given a project's net present value and internal result result from differences in the magnitude and the timing of the cash flows. So you can see that. Okay. So that's what goes on here. So the net present value it implicitly assumes that the firm can reinvest intermediate cash flows at the cost of capital. However, the internal rate of return approach assumes that the firm reinvests at the project's internal rate of return. Okay. All right. So these are the conflicts that are coming up. So here's an example again. Okay, and I'll go over this example in the. I guess we'll do this now. We should include it. All right. So a project has an initial investment of $170,000, and will provide operating cash inflows of. Here's the inflows. The net present value of the project, which you can calculate either with Excel or by hand at a 10% cost of capital, is $16,867, and its internal rate of return is 15. So the project is acceptable, right? It's everything's greater than the cost of capital. This is positive, so everything's hunky-dory here, okay? Everything looks real good, right? And you can get this internal rate of return again with Microsoft Excel. Now let's assume. Let's see what happens if we assume that the firm reinvests cash flows as they come in. Table 10.5 shows how much the firm can earn by reinvesting each intermediate cash flow at either 10% the cost of capital or 15% the project's internal rate of return. If we assume that the firm earns 10% on reinvested cash flows, the firm could accumulate this amount of money in 3 years. Now suppose we discount that value back to the present value using 10%. In doing so, we are asking the question, what is the project worth today? If it costs $170,000 and the firm can reinvest cash flows at 10%. And you could see it comes out to the net present value we talked about, all right? So that matches the number stated at the beginning of the example, right? The net present value approach assumes that the firm reinvests cash flows at the cost of capital. It is interesting that if the firm invests $170,000 today and 3 years later has accumulated $248,720, then its average annual return over the period is 13.5, not the 15% obtained in the internal rate of return calculation, okay? So this is telling you what the average annual return is. Next, assume that the firm reinvests intermediate cash flows at 15%. Table 10.5 shows that the firm can accumulate $258,470 in 3 years by reinvesting the cash flows as they arrive. Okay, so now you're reinvesting the cash flows as they arrive. If undertaking this project costs $170,000 and the firm can reinvest cash flows at 15, what is the project worth today, assuming a 10% cost of capital? Discounting $258,470 back to the present, we obtain this amount of money, right, at 10%. So the net present value then becomes, if you take this present value minus the 170, 24,192. This time the net present value is larger than it was before, and that difference is driven by entirely by the 15% reinvestment rate assumption. Table 10.6 summarizes the important lessons from this example, right? So here's the net present value again. But if the firm can reinvest cash flows only at the annual cost of capital, the project effectively earns 13.5%. The project's internal rate of return is 15, but that assumes the firm can reinvest cash flows at 15. If the firm could do so, the project would be even more valuable than the net present value calculation indicates. So here's that table. And it's important to go over this table, okay? So here's the inflows, right? Here's the initial investment. Here's the internal rate of return. So here's the future value at the end of the year at a reinvestment rate of 10. And here's the future value at the end of the year at the internal rate of return of 15.